Let us see how Reynolds series is built. So in this system, we divide the interval from 1 to 10 in steps of 5, 10, 20, 40 or 80, and we designate each of this series as R5, R10, R20, R40 and R80. If you observe the factor between any two consecutive numbers in the series, they will be constant because the entire series will be built by multiplying a constant number which is actually the fifth root of 10 in R5 series, 10th root of 10 in R10 series, and so on. So here you have the table, right? R5 series, fifth root of 10 is 1.58, 10th root of 10 is 1.26, and so on. So this table is available in the data book, so you need not derive it. However, you can always evaluate this nth root of 10, quickly get the series factor. So in each of these series, every number in the series will increase by 58% in R5, 26% in R10, and so on. How this series is established? Let us see how R5 series is established. See, we have the interval from 1 to 10. I have taken fifth root of 10, it is 1.58. How to build R5? So what should we do? We should take the first number. See, in all this series, the first number is 1. Multiply that first number with a series factor. For R5, what is the series factor? It is 1.58. Okay. So 1.58. So here you look at first number is 1. Multiply it. It is second number. It is written as 1.6. They have rounded it off. Okay. So you can round off to the nearest integer. Either you can seal it or floor it. Then how do you get the third number? Multiply 1.60 by again 1.58 and round off it to the next integer, that is 2.50, next decimal value. Similarly, to get the fourth one, 2.50 into 1.58. So until you reach this 10. So this is the way we develop the series using the series factor. So there are two ways we can derive our own convenient series by employing Reynolds series. Okay, so you can pick any of the term from the Reynolds series and build your own series convenient for you for building your own products. So basic series and derived series. If you employ the existing one R5, R10 through R80, we call it as basic series. That is what. If any series is formed based on the 5 basic series, we call it as derived series. For example, here we have a series represented like this: R10/3. Within the bracket, we are representing 1 comma until 1000. What is the meaning of it? It is a derived series. So every third term of R10 series is being employed in developing a series starting from 1 to 1000. Look at the third term of the R10, multiply it and until 1000. Okay. Second example, R20/4. Okay, so there is no upper limit and lower limit, but 8 has to be a part of your series. Pick the fourth term of R20 series and multiply here to get your this particular series, which is unlimited in both the sides. Then R20/3 with lower limit 200, there is no upper limit. Pick the third term of the R20 series from the table, multiply 200, that series factor, and keep on continuing to get your desired series.